السلام عليكم ورحمة الله. بسم الله الرحمن الرحيم. Today, inshallah, our class is going to start the query language, which is known as SQL, structured query language. SQL actually is the tool that we are going to use to deal with our database, to deal with our server, to control the server, to control the data, to design the database, to retrieve data, to insert data, to do whatever related to the database. Okay, so the query language or the SQL actually is the heart of the database. Is the heart of the database, or the most important tool that we need to use, or we need to learn to understand how to deal with data, how to process the data, how to retrieve it, how to format it, and everything. Okay. Before this, actually, what we have learned is we have gone through the introduction at the beginning. Then we came to the database design, chapter 2. So in database design, we learn how to design the entity relationship diagrams, then how to change them or transform them into real database design. After that, we learn how to use the normalization techniques to avoid the anomalies, to avoid the bad practice of database, and so on. For today, as I said, it's all about the query language. So query language is in general is 3 parts. We are going to learn them all. So the first part is to control the server and the database. The second part is to manipulate the data. And the third part is what they call it here, DDL, DML, DCL. DDL is to define the data definition language. And the other one is DML, which is the data manipulation language. This is to handle or to process, to manipulate the data, like insert, delete, update, and so on. Then we have the data control language, which is to control the database and the access to the database, users that's allowed to connect to the database, and so on. So based on this class, you will learn how to explain what is the SQL, and also to define a database using the SQL data definition. So how to create the database, how to create the tables, and so on. Then how to establish referential integrity using SQL. So how to create relations using the SQL commands, and also how to grant or revoke privileges to access database or to or particular object within the database. So this is how to control. Then here, let us start with this slide. What is the SQL? SQL in many places they call it SQL. Some people pronounce it like this, SQL, but I prefer to say SQL. SQL or structured query language is an English-like language used to create and manipulate database. So it's a readable language that's used to manipulate database. Manipulation of database could be the creation of table, creation of relation, deletion of an object like a table or relation or whatever. Also the insertion of data, updating the data, deleting data, whatever. Okay, everything is called data manipulation or database manipulation. Okay. 3 types of statements here, as I mentioned: DDL, DML, and DCL. DDL is actually used to define the structure of data, data tables or databases in general. And also it's used, the DDL is also used to create all objects of the database. That's related to the structure. It's not related to the data itself. So DDL is all about the structure, how to build or modify or manipulate the structure of the database. DML is all about the data, is how to manipulate the data itself, like inserting, updating, deleting, and whatever. Data control language is all about the control, how to control the security, how to control the access, how to control everything. Then data definition language creates and manipulates the structure that data manipulation language builds. Data control language determines who is allowed to what within the database. So data definition language, as you can see here, is all about creating and manipulating the structure. Data manipulation language is the language that will fill the database, the structure. Then the data control language is to determine who is allowed or not allowed to access anything in the database. Okay, let us start with the DDL. DDL actually is all about create or drop or alter. Create is to create whatever, to insert, to create the database, or to create a data table, or to create a relation, or whatever. Drop means delete. Drop means delete. So delete what? Delete table, delete database, delete relation, delete index, delete primary key, delete foreign key, whatever. So here, these commands are all about the objectives of the database. These three commands are dealing with the objectives of the database that's related to the structure. So all about the tables, relations, indexes, keys, and everything. So we can create, we can delete them, we can alter or modify them. So alter means modify. Drop means delete. Okay? So far, is it clear? Any questions so far?
No, doctor.
Okay.
Doctor, is this language is considered a programming language?
Actually, it's a query language, not a programming language, but also you can do programming for the database. You can program using the SQL, but that one is called database programming. That's only to build triggers or stored procedures or user-defined function. That's another level. Okay, so at the end of this course, actually, we are going to learn how to create triggers and stored procedures and everything. So don't be quick. Okay, just wait for it. Inshallah, you will learn everything. This is the start of the SQL. Okay, so the query language is all about telling you how to retrieve data or how to insert data into the database, and before that, how to create that database, how to create the tables that you want to fill them with data. Okay, so it's something similar to scripts. Okay, it's a kind of scripting, because even the commands are very limited. It's not a very huge number of commands. So as you can see here, the DDL part is 3 commands only: create, drop, and alter. Then inside the create, there are like 3, 4, 5 types of the creation. And the drop also depends on you are creating a table or creating a relation, or what you are creating or dropping. Okay? Then the DCL has 2 commands: grant, to grant a privilege, and revoke is to remove a privilege, to take out a privilege from someone. Okay, so for database, we have to have users. So users should be created, and also users could be created by the DCL commands. But anyway, the creation of users is out of the scope of this course. Anyway, I'm going to show you how to create using the SQL developer. Okay, this command grant is to give or to grant some privileges to certain user or group of users. Revoke is to remove a privilege from a certain user or certain group of users. That's all, very easy. Okay, then we go to the DML. DML is the most important thing because this one is the frequently used language. So frequently in every interface of your application, you are going to use the insert, update, delete, and select of data. So DML is all about manipulating the data. So the first thing is to insert. When the database at the beginning, at the first time after you finish the design, the database will be empty, right? So we have to insert some data. Then this data could be retrieved later to be updated, right? Or to be modified. Then maybe in some scenarios, some data is going to be deleted. And this select actually is to retrieve the data from database. So this is to add data. This is to modify an existing data in the database. This is to delete an existing data from the database. This is to read or to retrieve some data that exists in the database. Okay, is that clear?
Yes.
So how many commands we learned today? 3 as DDL, 2 as DCL,
9.
4 as DML. So in total, 9 commands. Okay, not that big issue. Very simple, inshallah. Okay, let us start with the DDL. DDL is here in this slide. We are going to show you how to create a table. How to create a table. So use the create keyword and specify the table name, field column names, and after that field type, then constraints like primary key, foreign key, or if you want to create another constraint like to check value based on another value, to check field based on another field, and so on. Then we may have not null constraint, or we may have a unique constraint. Also, we can put them. So the primary key is the unique identifier for a record. So we have to mention what field is the primary key. And also, if our table have a foreign key, then we have to define what is the fields that's related to this relation. The fields that's going to establish this relation, and what are the tables involved in this relation. So we have to define them here. Okay, this one check is value must be in the specified list. Not null must have a value. Unique value must be unique. So that's all about it. So the sequence of the components in the create command is to use the create keyword followed by the table name, then after that the fields. So for example, ID, type, make space, then integer, and after that comma, then name, space, string, for example, or invite char or whatever, and so on until the end. Okay, that's all about it. So here we have an example. Create table, room. The table name here, the table name is room. So here, this table will have room ID, and it will have BLDG. I don't know what is this, and it will have room number. Then we'll have the max capacity, style, and so on. So after every field, we should have a space followed by the type, then comma. So for the integer, we can use number. For the string, we can use char or invar-char or var-char2 or whatever. So this one, BLDG, is char. Char 1 means only one character. One character. Then here in front of this, we have a check command. So we have a constraint here. So the constraint is that the pledge, this one BLDG, must be in this group, must have the value A or B only. We cannot put C or D or whatever. It could accept only A and B. Anything other than these two is not going to be accepted. Okay? Then here we have the room number space, then the varchar2, the type is varchar2, means string, and the length is 10. That's all. There is no constraints here. Then we have the maximum capacity is number. Then the style is yes. Yes. Anything? I don't understand. What do you say?
It's lagging, doctor.
Lagging. What can I do? I cannot do anything. Yeah, okay. Here, let us complete then this video. Actually, this class actually is also recorded. Then I will share with you, inshallah. Don't worry. Style here is varchar2 also, and the length is 15. But here we have a constraint, so the style should be either lecture or lecture lab or lab or office. Okay, so we have 4 types of rooms. Okay, so this at the beginning I thought it's a hotel room, but now I understand it's a university or school room or whatever. Okay, so here we have lecture dash lab or slash lab, then lab only or office. 4 types of styles. Okay, so nothing we can use other than these 4 types. Constraint here, this one is a general constraint. General constraint here is to define the primary key. For primary key names, normally we use the table name underscore pk. Table name, like here, like this case, the table name is room. Then here, table name, followed by underscore, then pk. After that, one space, and we use this keyword, primary key. Then we open bracket and we put the field of the primary key. Okay, so the room ID, this one is going to be primary key. So everything we define as a primary key is going to be unique. Okay, that's all about it. So at the end we have to put semicolon. Between the columns and fields we have to put normal comma. Okay, we have to use comma between every 2 columns or fields. Okay, if you, for example, forget this comma here, you will have to an error message. Then you have to find where is the mistake. Actually, dealing with the SQL commands is not easy because the compiler is not that smart. It sometimes shows you, especially if you write a very complicated script here, then you forget something, then it will show you an sometimes general error that you cannot understand. So in this case, you have to go and piece by piece, you have to revise and review your script. Okay? Is that okay, guys? Is it clear? Is it clear?
Yes.
Yes.
Okay. Okay. Now what I want to do in this class, I want to show you together uh, practically how we can use this kind of commands. So everyone, if you want to open, just open your SQL developer. Then we copy this command from the slide. It's better if you can write it from scratch by your own, but because the time of the class is limited, then I have to copy and paste to make it fast. It's up to you. If you want to connect to the UBM server, it's okay. If you want to use your own local database, it's up to you. Anyway, here, when we open the SQL developer, let me here open the UBM server. Hopefully it can connect. It looks very slow. Yes, but finally it opens. Okay, here, if we open the tables, we don't have any table here, right? So what we want to do here is to click on the server, then we click this, and we select new database connection. No, maybe here, this button, new. We just click new, then we select here database tier, general contact, database object, file, database file, SQL file. Okay, so we click here on database file and we select SQL file and open. So now here the name of the SQL file is whatever you want to name, or maybe you keep it as it is if you don't want to change it. For example, test. Okay, so this tab is test here. Okay, and here is an empty page. So I already copied the command, right? As you can see here, create table room. So let us make it rooms. The table name must be in plural, and the table name must start with capital letter, not small letter. Also, the columns must start, or better to start them with the capital letter as well. Then here B L D G also capital, and here room number. I don't know what's the room ID and what's the room number. I feel like there's something wrong here. Okay, then here maximum capacity and the style. Okay, so as you can see here, all field names are in black. Only style is in blue, because style is a reserved keyword. So instead of using style only like this, we maybe make it room style. Okay, actually using the table name inside the column name is not good practice. Okay, so better if you want to use is like this, ID, like this, and BLG, room number, maybe we make it like this, for example, our number, or maybe room number is not that big issue, but here maximum capacity is enough. For room style, the style itself is reserved keyword, so we cannot use it. So we have to add something, maybe R style or room style, because the style keyword is reserved. So instead of this, maybe we try to find another keyword instead of style, maybe type, maybe whatever, then we can use it. Okay, here unnecessary spaces is not needed as well, so maybe we use tab only instead of all of this space. Okay, Then here the check command. In the check command here, as you can see, we have the same column, and we use the n. N means this field value must be one of the values in this group. The group is here, started with a bracket, ends by bracket. When you open a bracket, when you write commands like this, if let's say you want to write this, you want to write the group, you open the bracket, you must close it first. Otherwise, you are going to forget, especially if your command is very long. So open the bracket and close it. If let's say you want to use a single quotation like this, close it first, then go inside, write A, then after that put comma. You want to use another single quotation, open and close, then after that put B, and so on. If you want to use like this, maybe C as well, and so on. So this is the good practice that you could follow, because otherwise, if you don't open and close the things at the same time, then you are going to forget. Okay. Here, room number, maximum capacity, room style, and the room style need to be checked like this. Lecture, lecture lab, lab, office. Okay. Then we have the constraint. Constraint is also has a name for the primary key. This is the name of the primary key. And after that, we must use the keyword primary key, then the ID. Now the ID changed to only capital I and small d. Okay. And this one is rooms. Rooms, because the table name is changed to rooms. Anyway, this name is okay if you want to use anything. If let's say you want to use XYZW, for example, it's going to work. But later you will see the XYZW, you will ask yourself, what primary key is this? Because you don't know. You don't know. Or what constraint is this? Because you don't know even, is it primary key or not? Because the name is not descriptive. That's why you have to put the table name, rooms, then underscore BK. So from the name, you understand that this is the primary key constraint for the table rooms from its name. Okay. So if we run this, it's going to be working, inshallah. Let us make some mistakes. Let us remove this comma and we try to run. Okay. When we try to run, because we have two connections here in my SQL developer, it asks me, is it on FSKTM or local? I want to make it on FSKTM. Okay. So this one is not going to be working. Why? Because here error started at line 1 in command create table blah blah blah. Then you see this is line 1. Line 1 doesn't have any mistake. Line 2 doesn't have any mistake. The error is here, actually, is the comma, but we don't know where is it, because this one, as I mentioned, is not smart. So the error report here tells you that missing right parenthesis. While we did not miss the right parenthesis, we missed the comma, right? So this is what you are going to face. That's why when you try to write, you open bracket, you close it first, you open quotation, close it first, and so on. Let us try, after we correct this, let us try to run. What happened here? Also another error. Attempt to define a column check constraint that references another column. Yes, because this one is wrong. We changed the name of the field and we forgot to change it here. Okay. Let us run. Here, what else do we have? column check constraint cannot reference other columns. Then here column check constraint cannot reference other columns. Attempted to define a column check constraint that references another column. Is it? Let's check.
Maybe the curly braces.
What is this?
Curly braces.
Curly braces. We don't have curly braces. Okay, this is the open and the close. This is open and close. Open and close. Correct. Open and close. Open and close. Correct. Open and close also. Open and close. Then here open and close. And here also open and close. So we have comma here, comma here, comma here, comma, comma, and another. Here we shouldn't have comma. Okay, so what's wrong with it? I don't know. Let's delete this. Let's make a fresh one. To show the things here, we have to refresh. Okay, it looks like the table is not created yet. Okay, I don't know why. Maybe because the connection is very slow to the UBM server. We try to table room is created. Okay, here one more thing. When you run, you cannot select partial part of the command. If you do like this, then the selected part is going to be run only. That's why it will show you an error, unknown command. Okay, so either to click on the space, empty space, don't select anything, or to select the exact command that you want to run. So in our case, the command is already completed, so table rooms is created. If we go here, we cannot see the plus. We have to do refresh here. After this, we can see the rooms table. Okay, so this is the rooms table: ID, BLTG, room number, maximum capacity, and room style. Okay. Anyway, I told you that the column names must start with capital. But after that, after we run, you can see that all column names are in capital. So that's not issue. Just write it whatever, small or capital. By the end, it will be all capital. Okay. So as you can see here, the ID is number. No, not null, because this one is primary key. And also this one is BLDG char 1 byte, as we define it here in the command char 1. But here we cannot see the constraints, right? We cannot see the constraints. Later I show you how to see the constraints. Then we have the room number, var char 2, 10, length is 10, could be null, all could be null. Only the primary key cannot be null. They don't. We did not define any default value for these fields. Column ID is like this, 1, 2, 3. It's automatic. And comments here, we did not write any comment. That's why it's null. Then the maximum, the room style. We cannot see the primary key. We cannot see any constraint. If we want to see the other things here, we can right click and select edit like that. Okay, if we select edit, then we are going to see the primary key constraint here, as shown here as a golden key with star. That means golden key means primary key, star means unique. Okay, so the primary key is the ID field. It's not null, and the others could be null. Why? Because we did not mention. If let's say we want to mention that some fields are not null, then we have in the command to write not null in front of them. Okay. The other things, we have constraints here. So the first constraint we have is the BLDG. The primary key, rooms primary key involves only the column ID here. The primary key involves only the ID. It could involve multiple fields, right? If the primary key is a composite. But in our case, it's only the ID of the room. Then if we have indexes, the constraints, we still have the check here for the BLDG and the check for the room style. Okay, this is the constraints that we created. Then here we have the indexes, if we create indexes, but by default the primary key is going to create an index which is ascendingly sorted. Ascendingly sorted means from A to Z, from 1 to larger numbers. Okay? If descendingly means from Z to A, or from infinity to 0. Okay? Then here in memory we have many things. Actually, I'm not going to explain every small piece here because many things are not in the scope of this course. We have, if we want to write any comment, we can write it here. Then we have the DDL here, the command that we could use to alter the table. So if you forget to write the command or how the command looks like, then you can select here. If you want to create the table, this is the script, exactly the script that you use. Okay. If you want to update, you can update like that. So alter table room, then modify column. So if let's say you want to make the room number, you want to make it not null, for example. Okay, so this one is going to modify the room number and make it not null. While at the beginning we did not make this constraint, right? I hope this is clear. Okay, now after we created the table, then the table here exists, right? It's existing now. If let's say we want to run this command again, it will show an error. What is the error? Name is already used by an existing object. This name is already exists. Why? Because this table is already created before. So if let's say we want to modify, for example, if let's say we want to modify this room number, we want to make it not null like this, we have two choices, either to go here and table drop, or maybe to write drop command to drop this table or to delete this table. Then after that we run the command again, or we can go and modify this column for the existing table. Okay, let us see. Based on here, if you edit, go to the DDL, select update. I don't know why it doesn't show. Just now it was showing, right? Okay, no problem. If let's say we want to modify a table, we can say alter table rooms like this. Then we should say modify room number, and we make it not null. Okay, let us try this. Okay, table rooms alter. Okay, if we go here we run refresh first. We run refresh first because this is a bug in the tool actually. So if we go here, last time you can, as you can see here, room number is not null now, cannot be nullable. You see, because we already modified. So here you can see room number is not null. Okay. Also we can delete this table at all. Then we rerun the modified command here after we add the not null. Okay, so it's up to you. You can use either ways. Okay. So this is how to create the table. Now our table actually is empty. Okay, we can select star from rooms like this. Select star from rooms means retrieve all data from the rooms table. Okay, so here if we run this, the table is empty here. Okay, what if we insert? I just want to show you how to insert. So to insert, we can do many things. We can do it in multiple ways. So the first way is columns. There is no way to show it from here. Table, is there any insert? No insert. Okay, if we open like this, it will be like that. Okay, so we don't have any option. We have to insert. After insert, we have to write into table name rooms. Then after that, we could say values, and we open and close the bracket, then semicolon. Okay, here if let's say we want to put an ID for the room, for example room number 1, then BLDG must be either A or B or C, as we can see here in the constraint. So here we have to put, for example, B, for example. Then room number, for example, is second floor, for example, room 30. Okay, this one is varchar, right? So varchar must be in a single colon, in a single quotation. Okay, between single quotation. Then after that we have the maximum capacity, for example we say 2 or 20 because this one is a classroom. Then what do we have? We have the room style. Room style must be also between single quotation. So let's say this one is lab, and after that we have finished. Okay, so let us run this command. We select this and we run it. Okay, check constraint valid. What's wrong with it? So maybe because this one is capital here, we have to make it capital lab. Okay, yes, one row is inserted. Okay, so if we go here now, last time when we run this command, it shows nothing, right? But now if we run, it will show us this data, right? Why? Because this data is already inserted. Okay, what if we want to insert another record here, another record for room 2, for 13, second floor 14, also 2, this one is also lab, but the room BLDG, we want to make it D. Here in the constraint we have A, B, C, and now we want to make it D. Is this going to work? It's not going to work. Okay, you can see here, check constraint violated. So D is not there, is not accepted. Okay. Okay, if we make it, for example, B, then it's going to be accepted. What if we try to make duplicated, or we repeat the same ID, room ID? So in this case here, if we run, it will show unique constraint. Why? Because this value is already used and this field must be unique. Every entry must be different than the existing. Okay, so here this one could be used as this number 2. So in this case it's going to be inserted. So we have now 2 rows. If we select data, select star from rooms and we run, then we can see we have 2 records. Okay, you see how many things we learned now. We learned the command of create, then how to insert data into the table, then how to retrieve the data from the table. I just give you this because this one is not now, it's not supposed to be given now to you, but I showed you this to understand what we are doing. Because if I create the table, you may not understand that this table could receive data. But now you already understand that the structure is already created by this create command. Then after that, this structure could be filled by the DML commands like select, insert, and update, and so on. Okay? Any questions so far?
No, doctor.
Okay, good. Don't forget, we are still in the DDL. I give you some commands from the DML part, but don't worry about it. Just focus on the DDL now. The thing that we learn is how to create a table, how to create a check constraint, how to create a primary key constraint, and so on. Okay. Then another example here: create table faculty ID. Name, first name, I don't know. Faculty has first name or faculty means lecture or maybe staff. Yeah. Okay, so here they have faculty ID, lecture name, first name, department, office ID, phone number, email, rank. Okay, as you can see here, it's the same structure, right? We use create keyword, table keyword, then after that the table name, and we open the bracket here, and we have to close it here after the last column, right? After every column we have to put comma. Only the last column doesn't have comma after it. Then here we learn how to use the not null constraint after any needed field. Also how we use the unique constraint for any field. Then how to check like this: rank is in here, inst, ASOC, ASST, or full, senior, I don't know. So this is the types of the ranks of the faculty members. Okay. Then here we have constraint. So the first constraint is the primary key. The primary key should use the keyword primary key after it. Then after that, in between the braces, we have to put the field name, which is the primary key field. Okay. If let's say we have 2 fields, we put comma and we write the name of the second field, comma, the name of the third field. If let's say our primary key is a composite, okay? It's like that. Very easy. Okay. The new thing here is the constraint of the foreign key relation. Okay. So in here, it's similar to the primary key, but instead of BK, we use FK, and instead of the keyword primary, we use the keyword foreign. Okay. So foreign key, then after that, we select the key, the field from our table here that we are creating, which is the office ID here. And after that, we use the keyword references. Then we mention the other side table, and the room ID of it, because the office ID here is a room, right? So here, let me explain to you. Let me explain to you here. So here we have rooms, and here we have faculty members. Okay, so faculty member here have ID, room is also have an ID. Then here we have the office number. This office number is a foreign key, which is coming from that room ID. Okay, so this one is the reference here, and this one is the local field. So if we go here, this is the local field from our table that we are currently creating. This one is here. Then after that, reference is the reference table, which is rooms, and room ID is the column of the room table. Okay, is that clear, guys? Is it clear?
Yeah.
Okay, so what you have to do here, at the beginning, you have to understand the logic, the structure of the command. Then you have to remember all keywords. You have to remember all keywords needed to create tables and so on. Otherwise, you are not going to create anything. You are not going to be able to create anything. Okay, so here, let us create this faculty member, and we use ID here. As I said, the name of the table shouldn't be used for the column name. Then here, department, office ID, phone, email, rank. Okay, here everything is quite okay. This one is instructor, associate professor, assistant professor, full professor, senior. Okay. This one associate, this one assist, and I don't want to full senior. Okay. Then here we have the office ID. Office ID is here, and room ID is there. The table is already created as rooms, right? So we have to put rooms here. We have to put rooms. And the room ID, there is no field with this name, because here we created ID, not room ID. Okay? So we have to correct this. Okay, here as you can see, this one is to close. This one is the end braces for the entire command, and this one is the end braces for this. So we have to take it here, Control Z. We have to take it here, because this one here is closed here, and this brace is closed here. Okay, so if we select this and we run this, the table actually is going to be created, but here there is something wrong. What is that? Is the faculty ID. Faculty ID is no more there. This one. It's already changed to ID, right? Okay, so we run here. Then table faculty member is created. Okay, let us go here and refresh. Okay, faculty member is here. Okay, if we go here and edit, okay, here we can see the primary key is the ID of the table, and these three columns cannot be empty, cannot be null, and constraints are here. We have the primary key here, faculty primary key, which is involves the ID only. Unique here involves the email, and this one is also unique. Primary key is also unique because it's a primary key. Then the foreign key here involves the office ID from the local table and the ID from the remote table, which is the rooms. Okay. Here we mention what is the reference. What is the reference table? This is the reference table, rooms. And the name of the constraint is rooms primary key. Is it correct? It's supposed to be rooms foreign key, right? Supposed to be rooms foreign key as this here. But I don't know why it's like that. I think it's a bug here because this one is faculty FK, not rooms BK. I don't know why. Consider, or maybe this one is talking about the field that we selected, the field that we must select from the remote reference. Yeah, okay. So here we have something called on delete, no action, or cascade, or set null. So this is in the case if we delete. For now, it's not easy to understand or to explain this for you because you are still new. I am not going to explain this, but later we are going to come back to this, inshallah. So here, as you can see, we have another table connected to the rooms table by one-to-many relation. Okay, here in this command here, if let's say we want to insert into what they call it, faculty member. This one, the name supposed to be plural, right? Supposed to be faculty members, but we forget to make it. We forget to make the plural name for the table. So in this case, we have two choices. We can rename here. So instead of faculty member, we make it faculty members, like that. Apply. Has been renamed. Okay. So in this case, or maybe we can use the command to modify. Okay. So in this case, we are going to use faculty members. Then here we have to use the keyword values. We open and close the braces, and after that we see the sequence here, the faculty ID, for example 100, last name, for example, is I will put my name Russia, but this must be in between single quotations, comma, double single quotation, and here Muhammad, then comma. So last name, first name, then department. Department here is also bar chart, so it's supposed to be in between single brackets, single quotations. Then here, for example, what they call it, communication technology and networks, CTN. Okay. Then here we have office ID. Office ID. If let's say I just arbitrarily put 5 like that, I just put any number or make it null or whatever, because this one is the field of the relation, right? Then here, if let's say we have the phone number is varchar also. So for example, 011 0000000 like this, for example. Okay. Then colon or comma. After that, we have an email, and the email must be unique, right? Name at mail.com, for example. Then we have rank. So rank is char. but char 4 here, right? And we changed here, we changed the values. Last time it was only 4 letters, but now it's changed. So we can check here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the longest one. So we change it to 10. Okay. Here we put like that, and we put, for example, assistant. Okay, assistant. Then after that we finish. Okay, so this is supposed to be enough. So let us highlight this and run it. Okay, faculty member rank, actual maximum is 4. Yes, maximum is 4. When we created maximum size of this rank is 4. We changed it here, but we didn't modify, right? So what we have to do here is to alter table faculty members modify rank, and we make it, where is it, char 10. And also maybe we need to make it not null or whatever, so we have to make the things here. So not null, and check this. Okay, so this one is more than enough, so we modify this first. Table faculty members altered. If you want to make sure that everything is altered, you can check edit. You can check edit here, and you can see the rank here is 10 and not null. Okay, so after this, if we insert this data, the data should be inserted. What's wrong with it? Here, violated. Check constraint. What constraint is that? The constraint is here, because this one is assistant all capital, and this one is capital and small. Okay, so we modify this and run again. Parent key not found. Okay, this is the error that we want to have. So here it's an integrity constraint. Integrity constraint violated. Which constraint? It's the faculty foreign key. So the value of the foreign key here 5, while in our table of the rooms, we don't have room number 5, right? We don't have room number 5. We have only room number 1 and room number 2. So we have to choose one of them. If let's say room number 2. So in this case, it's going to be run. One row is inserted. Okay? If we select star from faculty members, then here it will show. Okay, so the office ID is 2. We cannot use 5, 10 unless they are saved in the rooms. Okay, you understand now the constraint of the foreign key is only to make the integrity, or to ensure the integrity of our data. Okay, is that clear, guys?
Yes, yes.
Yes.
Okay, so after this we are going to go here, table with primary key only. Table with primary key only is, I don't know why this slide is here. Okay, this one is a table with the primary key only. So as you can see here, the constraint of the primary key only, and here is a table with the primary key and foreign key. So in this case, we see the primary key constraint and the foreign key constraint. As I mentioned, the primary key needs the local field only, and the foreign key needs the local field here that's connected also to another table which is supposed to be mentioned after the reference. So we mentioned the table with the table ID. Okay. Here table.
Question.
Yes.
Can you okay for the constraint faculty FK foreign key, the reference, right? The reference inside the braces must be a primary key, or it's depend.
Actually, it's there is no point. There is no point to use a remote reference which is not a primary key. Okay, there is no point.
Okay.
Yeah, even if it's allowed, I think it's not allowed. But even if it's allowed, there is no point. No reason that makes you need to use a remote reference which is not a primary key. Because in this case, you are not going to ensure the integrity. Because any field which is not a primary key could be duplicated. So in your Dropbox, maybe if let's say you are filling up the information of faculty member, then you came to the field of the office ID. So in the user interface, you have to have a combo box or drop down list. So you click the drop down list, you see the available rooms, right? So the available rooms must be unique. If they are repeated, then you will ruin the things, right? So it will be very hard to deal with it, and also there is no point to use a relation. The foreign key relation must be between a local field that could be a primary key or non-primary key with a remote reference of another table with the primary key field. This is must. Okay?
Okay.
Yeah, again. If this is the field of the foreign key relation, this field could be a primary key or non-primary key in this table. Okay? But the other side, the remote reference here must be a primary key. So the foreign key side could be a primary key at the same time, or foreign key only, but the other side must be primary key. When we need to have foreign key and primary key at the same time, in the case of the table extension. So the case of one-to-one relation, if you remember. Do you remember that? Last time I explained to you. Anyone remembers? No one. So if let's say we have customer, and we have users. So the customer here has an ID, right? And this customer could, in one day, one customer become our staff in the supermarket, for example. So here, this will require a username and password, right? This user, he is already in our database, saved. His information, his profile is totally saved in our database. But he does not have a username and password. What to do here? We have to create a record for him to attach for him a username and password. So in this case, this part actually is an extension, right? Extension. This one is a primary key. And this one is a primary key, right? But the relation is here. So this one become also foreign key. So primary key and foreign key at the same time with only primary key. The remote reference must be always primary key. Okay? Is that clear?
Clear. Thank you, Doctor.
Yeah.
Clear, Doctor.
In some databases, you can reference non-primary key field as a remote reference, but there is no point really. it could make the system really, I mean, in wrong situation. And also in the user interface, it may show an ugly data or ugly interface that's not useful at all. Okay, so that's why you need to avoid having this case. Okay, table with compound primary key. So compound primary key is very easy. Instead of mentioning, like here, mentioning one column in the primary key constraint, we just put comma and put the other name. Maybe the if the primary key is the room ID with the room number, for example, it will be like this: room ID with room number. Okay, very simple. There is nothing complicated. Okay, as you can see here, the primary key, where is it? Primary key. As you can see here, we have event ID, we have member ID, and between them there is a comma. Okay, so this one is participation table. So the participation table is only to attach a member to an event. So the primary key must be the combination of these two fields. And as you can see, the table doesn't have any attributes other than the foreign keys, right? Only the primary key and the foreign key. There is no extra attributes, because in this case, this one is only to assign member to an event. We don't care about the date, we don't care about any other information. We only need to know which member is involved in what event. Okay, as you can see here, the primary key is this combination of the event ID and the member ID, and the constraint, the first constraint, which is the first foreign key. The first foreign key is because when we have multiple foreign keys or multiple constraints similar to each other, then we have to differentiate their names. So the first thing, we put the table name here, underscore, then the name of the remote table, the reference table, event, because we want to create the foreign key for the event ID with the events table. So here we put the first name, local table name, remote table name, then underscore foreign key, then after that foreign key, the local field here, and the remote reference, which is the table event with the event ID column. After that comma, then we start to create the other constraint. The other constraint is between the participation table and the member table to create the other relation with the member ID, and also followed by the FK, foreign key, then the local member ID, and the remote reference with the table, with the remote table member and member ID. That's all about creating the primary keys and foreign keys. Okay, now we came to the DDL altering table. DDL altering table is already given to you. I altered the table many times here. So I altered the table to modify the column, to insert the not null, to change the size from 4 to 10, and many things, okay? And also this table was altered at the beginning, the rooms table, okay? The command is like this: alter table, then the table name. Then when you open the table for alteration, there is two scenarios or three scenarios. The first scenario is to add a new field to the table, to add a new field to an existing table, or to alter an existing table, to alter an existing field in an existing table, or to modify an existing field in an existing table. So in this case, you will use alter table invoice, similar to the top one, exactly the same, but instead of add here, you need to use modify. When you modify, you have to write everything from scratch, everything related to the column from scratch. Even if you at the beginning mention the size or mention the constraint or whatever, you have to repeat. Okay, so that's why when you modify a column, before that you have to go and check what is the existing code, what is the existing constraints, what is the existing everything. Then you repeat them again. Okay, or maybe you use the user interface, the wizard, to modify like this, edit, or maybe table here, rename, drop, truncate, lock, parallel, whatever. Here, columns, you can see, rename, add, drop, normalize, comment. So if let's say you want to add a column here, easily use this wizard and put the column name here, then the type, precision if you want, scale, and so on. Or maybe the code here. The code here is like this. I don't know why. Very complicated. Just forget about it. So that's all about it. Very easy. So we can apply, then the column would be added. Okay, we can check here. No, an error was encountered. Performing the requested operation. The length specified was greater than 4,000. Which one? It didn't mention anything here. Watch out, precision, scale. Crazy. Okay, let us say 10 like that. Column has been added. Okay, now if we refresh, okay, this is the column that we insert. But here you cannot delete like this. You cannot delete. You go here, you can select this and drop. Okay, drop, cascade, drop selected column. Okay, apply. Okay, and you can see here the column is already deleted. But if we click here, if we refresh, here refreshes in. Okay, here we can see that the table column is already deleted. So we have many choices, either to use the command to alter or to modify, to add, or whatever, or maybe to use the command like this, alter table, to add a new column. So if you add a new column, you have to mention its name and its type, and also maybe you want it to be not null, for example, not null like that. Then if you want to check or whatever, you write. Okay, that's all about it. And if you want to modify an existing column in an existing table, then you have to use the command alter with the modify command. Then if you want to delete the table itself, you want to delete it, then you use drop table and the table name. So in this case, the table invoice will be deleted. And if you delete a table, or if you delete any component, you will never be able to retrieve it. There is no dust bin. Okay, it's not like the files. When you delete, you can find them here in the recycle bin, and you can restore. No such option. Okay, so before you drop anything, make sure that you don't need it anymore. Okay, the other thing is, if the table is referenced by a foreign key, use the cascade constraints clause. So drop table invoice cascade constraints. Okay, what does it mean? This one, if let's say we use this table as a foreign key here in the other table, so because of this relation, we will not able to delete this table. We cannot delete this table unless we delete its ID from here, from this table. Because if this table is used by other tables as a foreign key, then it's not going to be deleted unless we break this relation first. We delete this relation first, or we delete this table first, then we come and delete this table. Okay, is that clear? Because if there is dependency on the table, we cannot delete it. Also, if let's say like in our example here, just now, we use the room number 2, right? Here, for the faculty member. So what if we go to the rooms and we delete the room number 2? We delete room number 2. Let us try. Okay, here, delete. Delete from rooms where ID rooms dot ID is equal to 2. Okay, like that. So we want to delete room number 2. If let's say we want to use integrity constraint, faculty FK violated, child record found. Child record is the record saved in the faculty member, because this one, the room number 2, is a parent to the faculty member al-Rashah, right? So it's a higher level. So instead of doing this, we have to either to go and delete the record of Muhammad al-Rashah, or maybe to change his room first, then after that we can delete room number 2 if it's not used in other tables. Is that clear, guys?
Clear.
Okay. What if we use the cascade command? If we want to use the cascade command, here, then the record of al-Rashah is going to be deleted first, then after that the record of room number 2 is going to be deleted. Okay, but this one need to be mentioned in the setting. If let's say here in the setting, I will show you how to make it, because just now I told you that there is some options I'm not going to cover. No, where is it? Constraints. Yeah, this one. The foreign key constraint in every table, we must we could mention, if let's say we used no action, if the parent record is going to be deleted, this table is doing no action. But if we use cascade, then if the parent record is deleted, this child record is going to be also deleted. Okay, or maybe set null if this one is allowed null. Okay, it's up to you. So if let's say we make this cascade, so as you know here, let us show you rooms. How many rooms do we have? We have room 1 and room 2. And how many faculty member do we have? We have faculty member number 100, which is in the room number 2. Okay, what if we delete room number 2 now? Okay, one row deleted. Okay, let us go. We deleted what? We deleted the room, right? Room number 2. We did not delete any faculty member. But if we go and check the faculty members here, we are going to find that the member number 100 is already deleted. Why? Because we use the cascade, right? So that's why cascade option is very, very dangerous. Very, very dangerous. Don't play with it. Don't play with it unless you understand what you are doing. Okay, here, never put cascade. Really, my advice, never to use cascade. Okay, always make it no action. This is for your safety, for the system's safety, for the stability of the system, for the guarantee of keeping the information all the time. Otherwise, you may lose some information without intention. Okay, this is very, very dangerous. Okay, guys? can roll back actually. Roll back. Rule completed. Let us check here. Still empty, because I think it's ruled us back to the initial stage. Okay, anyway, we are not in this thing now. Okay, any questions so far, guys?
So doctor, if we want to delete the foreign key, we must use cascade, right?
No. No.
So then how? So if we want to delete foreign key from the primary key, is it we use cascade? I'm
Yes.
not clear about that.
Okay. Technically, it's like that. In order to delete a child record, you must delete the parent record first. This is technically. But logically, there is no such case that requires you to delete some records with its childs, because this is not a good practice. When you have data in your system, we never delete the data. Even if we want to delete, we just hide it. We just put a flag for the record that this record is deleted, but we keep the record. You understand what I mean?
Yeah.
Yeah. Never delete data unless your top manager or the owner of the system wants to delete. If the owner of the system wants to delete, then we can do it in other way. But my advice in your design, never use cascade. Never, ever. Okay? This one is very dangerous, and it may let you lose your job. If you make it and somebody deletes something without intention, he wants to delete the room maybe because its name is not nice and he wants to modify its name, and that room is used by a faculty member, then the faculty member has some subjects and the subjects have some students, then everything as a child is going to be deleted. You know how catastrophic is it? Yeah, it could delete the half of your system data, especially if the record you are trying to delete is the top level table. So it's very, very catastrophic. Okay?
Okay, doctor.
Yeah. So if for example, when you design, never use cascaded, but if let's say your top manager or the system owner ask you to delete all rooms and all stuff they have in the system, then you just go to the child. If let's say your system is like this, you have one table here, this is level 1 or level 0 as I mentioned before, then another table that's also having a foreign key relation here with that, this is level 1, and third table which is level 2 also has a relation here with foreign key. So this one is parent, this one is child 1, and here is child 2. So if let's say here we have 10 records, for example, related to one record here, and this record is related to another record here. So in this case, in order to delete all of these things, you have to delete this 10 first, then after that go and delete this, then go and delete this. So the deletion sequence is going to be like that, from below to up, from down to top. Okay? But never use cascade, because cascade sometimes allow deletion unintentionally. So by mistake, you can destroy the system. You can lose everything in one click. Especially if the system is like that, maybe this table is the top level table, and every table in the system is connected to that, like this. Everything is connected here, everything is connected here, and you come here and you deleted one record. So all related records here in the system is going to be deleted. Okay, I will give you a real example. If let's say you are using Lazada, for example. Everyone, I think, knows what is Lazada, right? If you want to use Lazada. Okay. For example, you are the system, maybe the responsible person in the system to insert or delete items. Suppose that this item, the one that you see now, just now, or maybe this watch, this smartwatch, has been sold, for example, 1,000 times. 1,000 times, for example, okay? Then you suddenly deleted with cascade, deleted this item with cascade. Do you know that the 1,000 orders that include this watch is going to lose this record? So if you want to check that orders that already includes this watch, you will not find the watch anymore in that record, in that orders. So the 1,000 orders are going to be wrong later. So your system will be in an inconsistency situation. Okay? You understand?
Doctor, can you repeat back because you are stucking a little bit.
You
Can
mean
you repeat a little bit just
the
about the
scenario
Lazada
of
one?
Lazada. Okay. So when you search in Lazada here, for example, you search about smart watch. Okay, it will show you how many times it's sold, right? No, it's not here. Maybe show me. Shopee or Lazada, it's the same case, but I want to show you some information only here to make it easy for you to understand. Smart watch here. Okay, here you can see this item, this watch has been sold 8,800 times. So this watch is a part of 8,800 orders. If you check this 8,800 orders, you will find one record in every order, including this watch, right? So if you go to the system and delete from the items table, you deleted this watch from the database, then 8,800 records in 8,800 orders is going to be deleted. You understand?
Yes.
Yeah, so that's why this is very dangerous. Never ever do it. Okay? Okay, indexes. Indexes here is actually used to speed up the performance of your system. So conceptually similar to book index. When you have your book and you want to access something very quickly, you just go directly to the index, check what page number is the thing that you are looking for, and directly go to the page number. How easily you can find the page number? It's very easy. Why? Because there is a sorting matter of the book pages, right? So the book pages are ascendingly sorted. So page 1 first, then page 2, page 3, page 5, and so on. So if let's say you are looking for page 50, then easily you can open the book from anywhere near to the 50, then you check. If let's say you find it 60, then you just go back a little bit. Easily you can find it. Otherwise, if let's say the pages are not sorted ascendingly or descendingly, You imagine how hard it is if you want to find page number 50 or page number 100. Can you imagine that? So it's exactly the same in the database tables. So database tables also have many records, and every record is similar to the book page. So in order to get easy access or fast access to a certain record, you have to have index. So all the records must be ascendingly or descendingly ordered based on one or two or three fields. Okay, depends on the scenario. So it will increase data retrieval efficiency. It will increase data retrieval efficiency, exactly like when you search a book for a certain page. Automatically assigns record numbers. So in every for the index, the index automatically will assign record number for every record. Then it's used by the DBMS, not by the user. You are not going to use the indexes. You only need to define them. If you did not define indexes, the system is going to define its own. Okay, but to make it easy for the system to improve its performance, you better define your indexes. How to define your indexes? By defining the primary keys, by defining the foreign keys, by defining extra indexes for the fields needed to be used to retrieve data. Okay? Fields on which index build called index key. So if let's say you index the table based on the first name, for example, then the index key of your table is the first name. Okay, or the first name field is going to be known or called index key or index field. Okay, have a sorted order. So every index has a sorted order, either is descendingly or ascendingly. So ascendingly means from A to Z, descendingly means from Z to A. Okay, can guarantee uniqueness. So index actually could guarantee the uniqueness of the field. Could, okay, not not must. Okay, can include one or more fields. The index is also similar to the key, primary key. It could be also a single field, and it could be composite field. Okay. Then here the index syntax. How to create the index? Here, to create an index, you can say create unique index. So if the field is unique, or maybe create index only if the field is not unique, like customer name. Okay. Also here, when you create a unique index, you need to mention what is the data field or what is the attribute. Sorry, this is what is the index name. Index name should include the table name and also the field name, and then should have this IND to mention that this is an index, like the PK, FK for the primary key and the foreign key respectively. Okay, so IND means index. So here we have the table name, column name, then IND. On this table customer, on the field of name. Okay, or maybe we create the index that's not unique. So in this case, we don't have to mention the unique keyword. So we directly use the create index, and we put the name of the field on table. Then after that, we put the name of the constraint or the name of the index, customer num. Okay. So this is an opposite way. You can use either, and here create index, credit limit, rib underscore index on customer that's based on two columns. So this index here is based on two columns, which is the rib number and the credit limit. Okay. Also, you can drop the index by using the drop index keywords, then followed by the index name. Okay? That's all about the indexes. Here, customer table with record numbers. So record number is generated by the system. So every record, no matter how what is the value of its primary key, it's going to have a record number. Okay, that record number actually is ascendingly sorted. So starts from 1 to infinity. Okay, if you resort or re-index the table based on, for example, the customer number or the customer name, then the record number is going to be changed. So it will show a sequence based on the ordering that you used. Okay, so here, as you can see, the index is something like that. So the index will include record number 1, will have the customer number 148. Record number 2 will have the customer number 282. So if, let's say, you want to update the record of the customer number 524, then the system is going to immediately go to the record number 6 in the table to retrieve this information immediately. Otherwise, if we don't have this index, then the system have to go one by one for all records to find the 524, because all pages here, all records here are not sorted in a certain order. Okay, is that clear, guys?
Clear.
Yeah. Okay, here, if we have table index on credit limit and RIB number, so in this case, credit limit is indexed based on the record number. Here, people who have credit limit 5,000 is the numbers 4 and 8. And RIB number here, people who have RIB number 20 is this records 1, 6, and 10. So if, let's say, we want to retrieve people who have the RIB number 20, then easily we can retrieve this records. Record number 1, record number 6, record number 10. No need to fetch all records. Okay? Indexes, pros and cons. So what's the advantages and what's the disadvantages? The advantages of indexes is to make the performance faster and more efficient for the data retrieval. Okay, so your data retrieval will become very fast. That's why if you design your system without using primary keys, foreign keys, then your performance is going to be very, very slow. What's the cons of using indexes? Cons of using indexes, because indexes will require additional space to be saved, because indexes are going to be saved as tables like that, right? So it's going to consume additional space, but this one actually is no more a concern, because nowadays the storage devices are very huge. Now we are talking about tera and even more, terabyte and even more. So don't worry about the space that's going to be consumed by the indexes. Last time, before 10 years or maybe 15 years, it was a very huge concern, because the last time before 20 years, the spaces was only with megabyte. Last time the memory is only like 8 megabyte, 16 megabyte memory for the computer. And also you may buy a desktop with only 100 megabyte, which is very huge that time. But nowadays we already know the gigabyte, and also we know the terabyte and even more. Okay, so that's why the additional space used by the indexes is no more an issue. No more an issue. Okay, then the other one, increased overhead. Increased overhead, yeah, to maintain the indexes, you have to do some process. So in order for the DBMS to save all of this index, it has to go through the entire table of your database. In every table, it will go record by record to fetch some information to create the index. But this one actually is going to be done periodically, so from time to time. And also you can schedule. You can schedule when you are going to do your maintenance, index maintenance, and even you can make it manual. So maybe like many systems, like bank systems, for example, CIMB, Maybank, or whatever. At night they do their maintenance. So maybe from 11:30 or 12 at night, middle night, the system will not be responsive. So if you want to log in, if you want to do any transaction, you will not be able to do that. Okay? Why? Because they do the maintenance. They back up their data, they maintain their indexes, they rearrange the whatever in that time. Okay? So it's very, very important to make your performance fast and efficient. Okay, no matter how size it is going to consume, and how much overhead it's going to add to the system, don't worry about it. It's really, really recommended. Okay, then we come to the DCL. Actually, I'm not going to cover it by today. I'm going to stop here. So we stop here. Okay, so tomorrow inshallah we are going to continue this until we complete. Okay guys, I hope you understand everything I explained. If there is any question, please let me know. Any questions so far?
Doctor, one question.
Yes.
Okay, for example, like metric number, right? Student metric number.
Mm-hmm.
Can indexes generate automatically, like if it's a primary key, but can they generate for us? Did we define the metric number, or the system define the metric number?
Okay, it's like that. I will tell you something. It's very rare, very rare to create index for a non-key field. Okay, it's very, very rare. Don't worry about it. You just take care about your primary keys and foreign keys. This is the minimum to ensure the good performance. This is the minimum. But if let's say you have in your website, maybe, or in your application user interface, you have a field or a page to search about some things, maybe to search about a student name, or maybe to search about the what they call it course name, or whatever. So in this case, the things that's used for searching by the users, it's better to be indexed, even if they are not keys. Okay. So we never index every field. This is going to be later very bad experience, very bad practice. Okay. So we only make sure that we use primary keys and foreign keys whenever we need, in the correct manner. Then we only index fields that's used for searching. Okay. When you create your
Okay.
primary key, the DBMS is going to create the index automatically for you. And also, if you make a field as unique field, then also it's going to be indexed automatically. And you don't have to do anything in this regard. So your queries later will be the same. Either the field is indexed or not indexed. The commands of retrieving data is going to be the same. Okay?
Okay.
Yeah. Any other question? Any other question,
No.
guys?
No.
Okay. thank you for attending my class, and inshallah I see you tomorrow on 10 o'clock, inshallah, 10 o'clock morning. See you tomorrow, inshallah. Assalamu alaikum.
Waalaikumsalam. Thank you, Doctor.
Thank you, Doctor.
Welcome.